Hello everyone, welcome to this next question on complex analysis. The question given here is that u of xy, this function is given to be 2x into 1 minus y for all x and y which are real numbers. Then they're asking the function v of xy, the function this one v of xy, this function is which among these four? So out of these four, what is this function v of xy, such that the condition is that this f of z consisting of u as the real part and v as the imaginary part, this function, this is given to be an analytic function. So here the given condition is that this function f of z, this is analytic. Now if this function is analytic function, that means it would follow the CR equations, the Cauchy-Riemann equations. And what are these equations? The equations are the partial derivative of the function u of x with u with respect to x, that would be equal to the partial derivative of the function y with v with respect to y, and second equation is the partial derivative of u with respect to y would be equal to minus the partial derivative of v with respect to x. So if these two conditions are fulfilled for any of these four, then we'll say that the corresponding v is that one. So here let us check one by one these conditions. So before solving these conditions, our u of xy, that is given to be the function 2x into 1 minus y. So now we'll first compute what is the partial derivative of u with respect to x. So it would only be 2 into y minus 1 minus y, because here this and these would be treated as constants because the derivative is only with respect to x. So and what is uy? Uy would be 2x as such, and the derivative of 1 minus y would be 0 minus 1. So it would simply be minus 2 of x. So this is our u of y and this is our u of x. Now for each of these options, let us compute v of x and v of y. So for the first case, we have v to be x square minus y minus 1 whole square. So let us compute v of x first, the partial derivative of v with respect to x, that would be 2x. Now according to this condition, this v of x should be equal to minus u of y. So minus u of y is minus 2x. So these two are equal, therefore first condition, that is satisfied. Now let us calculate v of y. What would be that? Here this term would become 0 because it is independent of y, and we are taking the partial derivatives, and the partial derivative of this term with respect to y would be minus 2 into y minus 1. So now this v of y should be equal to u of x. So here this thing could also be written as, when you take the negative sign into the brackets, you can write this as 2 into 1 minus y, right? So now this term is equivalent to this term. So this second condition is also satisfied in this case. So we can say option A is the correct option. But what about the others? Let us also check the same results for the rest of the options. So for the next option, we would again calculate v of x, that would be 2 into x minus 1, and v of y, that would be minus 2y. Now v of y from here is not equal to u of x, so first condition is not satisfied, so this option is incorrect. Similarly, we'll check for the third option. The third option says v is given to be x minus 1 whole square plus y square. So let us calculate v of x, right, vx. So it would be 2x minus 1. So now this vx is not equal to minus uy from here. So this condition is also not satisfied, this condition. Therefore we'll say option C is also not correct. For the option D, we had v to be x square plus y minus 1 whole square. So now computing v of x, that would be 2x. So now v of x is 2x, and what is u of y? U of y is minus 2x. So here in this case, the condition uy is equal to minus vx, that is satisfied. Now let us calculate v of y. V of y in this case comes out to be 2 into y minus 1. So now here v of y, is it equal to this ux? Ux is 2 into 1 minus y. So these two, they are not equal. So the second condition, u of x is not equal to v of y in this case. Therefore, this option D is also not correct. So the only correct option in this case is option number A. Well, that is it for this video. Thank you for watching.